Okay, let's take a look at a difference of squares and examples of where we have to factor them. Now recall that a difference of squares from the note there in the PowerPoint presentation has only two terms. And the terms have to be perfect square terms. And that means they have to contain perfect square numbers. So perfect square numbers are the numbers 1, because 1 times 1 is 1, 4, because 2 times 2 is 4, 9, that's 3 times 3, 16. Next one is 25, 36, 49, 64, 81, 100, 121, and so on, 144. These are perfect square numbers. So your terms should contain those numbers, okay? And in addition to containing those numbers, the terms have to be separated by subtraction, hence the word difference. Difference is the answer to subtraction. So two terms have to be perfect square terms. They must contain these numbers, and they must be separated by subtraction. So if your expression fulfills those requirements, it would be a difference of squares, and once you recognize it, it's a lot faster to factor it using the shortcut that I'm going to show you rather than using decomposition or ratios. So let's look at the first example of x squared minus 1. We got two terms separated by subtraction. The two terms contain 1, which is a perfect square number. Since it's a square and we need to reverse that, we're going to take square roots of the terms. So taking the square root of 1x squared, we get x. And taking the square root of 1, we get 1. So each factor is going to have those terms of x and 1. The signs in the brackets will then be different. One bracket will have a minus, one will have a plus. It doesn't matter where you put the plus or the minus. So this is the factored form of x squared minus 1. So square roots of the outside terms, x and 1, and then opposite signs in the brackets. Okay, let's look at the next one. We have 25x squared minus 36, two terms, 25 and 36 they're perfect square numbers, and the terms are separated by subtraction. All we have to do is take the square roots of these terms. So square root of 25x squared is simply 5x. Square root of 36 is 6. So each bracket will contain the terms 5x and 6. One bracket will have a plus, one will have a minus, and you're done. In the next one, if you look, again, this is a difference of squares, 625 and 144. They're perfect square numbers separated by subtraction. So if we take the square root of 625, we get 25. If we take the square root of 144, a squared, we get 12a. So these are the terms in each bracket. Okay, one bracket will have a plus, one will have a minus. Okay, you could still factor it using ratios or decomposition. So for example, if I look at part B and I try, let's say ratios. So if I look here, my product, if I multiply the outside numbers together, would be 25 times 36 is 900. And my sum is actually, because I don't see an x term, is 0. So I'm looking for two numbers that multiply to give me 900 and at the same time add up to 0. Those numbers would be 30 and negative 30. Now I write the ratios. So my leading coefficient would be 25. And it's going to be followed by positive 30. And then it's going to be followed by the next time in the next ratio by negative 30. Putting them in those terms means I divide everything by 5. I get 5 to positive 6 and 5 to negative 6. And then I add the variable x. So I get 5x plus 6 is one factor and 5x minus 6 is the other factor. It's exactly the same answer we got, but it took us longer to do that. So if you can recognize a difference of squares, you can quickly factor it, okay? Let's look at the second example. This is factor fully. So just like with simple trinomials and other trinomials, you always have to look for common factors first so that you're working with smaller numbers, because if I look at A2, we have 8x squared minus 18. At first glance, it doesn't look like a difference of squares because 8 and 18 are not perfect square numbers. When I take their square roots, I won't end up with whole number answers, as I should with perfect square numbers. So in this case, I'm going to look for a common factor. So 8 and 18, they're both divisible by 2. I'm going to remove it, and I'm going to be left with 4x squared minus 9. Now, the expression inside the brackets is a difference of squares because 4 and 9 are perfect square numbers. So I'm going to factor that expression by taking the square roots of 4x squared and 9. Square root of 4x squared is 2x, square root of 9 is 3. So each bracket would contain those two terms. One bracket will have a plus, one will have a minus. Okay, so not only am I working with smaller numbers, but also originally you wouldn't have been able to factor it if you tried just taking the square roots. So let's look at B. Greatest common factor of 48x cubed minus 27x, and that would be 3x. If I factor 3x out, I get 16x squared minus 9. 16x squared minus 9 is a difference of squares. Taking the square roots of each term, I get 4x and 3. That's what's going to appear in each bracket. One bracket's going to have a plus, one will have a minus. Here, I really, do I have a common factor to remove here? Well, no, I don't. So I'm just going to factor this difference of squares by taking the square roots of each term. So square root of 36x squared is just 6x. Square root of 49y squared is 7y. So each bracket's going to have 6x and 7y. So one bracket will have a plus and one will have a minus.